here's me. And then if you guys talk, it goes right on there. Dumb questions are okay. Lots of people have dumb questions. They need to be answered by somebody. Okay, so we're going to do motion in 2 dimensions. This is the start of Chapter 6. We do start with 6.3 today. Chapter 6 is kind of a hodgepodge of things. It talks about, basically takes vectors and applies it to all those things. So we did kinematics before. We did forces, and then we did forces in 2 dimensions, which is that test that you just took that you all failed.
Wait, do it like yesterday?
Yeah. Okay, so now what we're going to do is we're going to take these 2 dimensions idea, we're going to apply it to all those things that we haven't applied it to yet that we've already learned. So we're going to apply it to kinematics. We're going to apply it to circular motion. That's kind of a, you're going to start doing circular motion here in the next couple of chapters. And we're going to apply it to relative velocity, which is what we're talking about today. Relative velocity is really just adding vectors. So just like we did at the very beginning of the year where we are adding vectors, we're going to do that but with velocity. So the hardest part of this is the naming part. Once you get the naming part, it's just this vector stuff. Okay, so 6.3, relative velocity. We're going to talk about boats and trains and buses and things. So we're going to add velocity vectors and find relative velocity. So here's the easy stuff. And most of your homework questions and like EOC questions and test questions, they're all either going to be in a straight line, so back and forth like this question, or at a 90-degree angle. I will do one example for you that is not at a 90-degree angle. It's the hardest possible question you could ever get on relative velocity. I mean, unless you're talking about like at speeds of light, and that it's a little bit more. That's like physical mechanics in college, which we will not be talking about. So let's do the easy stuff first. Imagine you're on a train, and this train is going 15 meters per second. This train is going this way. So 15 meters per second, and you're sitting on the train. How fast are you going relative to the train?
15 meters per second.
To the train? Train's 15, and you're sitting in the train. How fast are you relative to the train? You're not moving relative to the train, because you're sitting on the train. Okay, so how fast are you going relative to the ground?
15.
15, there you go. Okay, you get up and you walk 2 meters per second towards the front of the train. How fast are you going relative to the ground? 17. 17, good. And then how fast are you going relative to the ground if you walk 2 meters per second towards the back of the train? 13. Okay, so see, super easy, right? Okay, the only time it gets tricky is when you start to add angles in there. So that is what we're going to do. But basically, the idea is, here's the naming process of that. VAV plus VBC gives you VAC. This is kind of like the transitive property in mathematics, where if A equals B and B equals C, then A equals C. This is very similar. So what you're going to do is this would be the velocity of A relative to B, the velocity of B relative to C, and that's going to equal, basically your B's cross out, they need to be next to each other, the velocity of A relative to C. So you want to set up your equations so that these B's always cross out. So you're going to use this equation. I'm going to use my fancy pens here. B, A to B, B to C is going to equal V. Basically, B's go away, A to C. Now, sometimes when you're doing these things, you might get V, C to B instead. And you need to make sure they're in the correct order, otherwise they're not going to cross out. So if you need to flip it around, you just make it negative. And those two things will cross, or will flip. So now VCB is equal to negative VBC.
Okay, so you made it negative, like what? You can't just put it in that way? Like if
I couldn't just put VCB in, otherwise the B's will not cross out, because the C is going to be in front instead of the B. That's the hardest part of today. I mean, next to like remembering how to do the vectors and stuff. That's like the new information.
Like when you plug numbers into it, how are you going to know like which one's going to put next to each other?
You have to read the question.
Oh, okay.
It'll tell you. We're going to do one. Okay, so you're really just adding up, and we're going to add angles to it so that you can see it with vectors. So here is my very hard question for us to practice. You're on a boat now. No singing on the boat song. Something about Poppy Floppies.
I sang for my game.
Okay. I knew somebody was going to get it. Okay. The boat is moving in the water at 10 meters per second, an angle of 80 degrees north of east. So let's break this apart before we go any further. It says the boat is moving in the water. So here is the velocity of the boat relative to the water. And I got that just by reading the sentence, the boat to the water. It is 10 meters per second at, and it says 80 degrees north of east. That's already proper angle, so we'll just leave it at 80 degrees. And now you're on the boat, and you walk at a 45-degree angle to it. So this is the velocity of you relative to the boat. The boat is your velocity relative to the boat, so YB is 2 meters per second at 45 degrees. So basically, and don't worry about the pictures too much because they get a little confusing, but here's the boat, and here is your 45-degree angle to it. So this is 80, that's the one in between is 45. And again, don't worry too much about the pictures because they're really confusing. Okay, so we have the boat to the water, you to the boat, and we're trying to figure out what is your velocity relative to the water. So what is your velocity if you walk 2 meters per second and an angle of 45 degrees? I'm reading into this just a little bit because I wrote this problem and it's not that great. Yes?
How did you know it was relative to the water there?
Again, I have to read into it a little bit. Yeah, your questions will be a little bit more straightforward. Okay, so now I need to construct the equation. I'm going to start with this first. I'm not going to worry about these yet because I might have to put negatives or whatever to make them work. So I'm going to start with this. And I go, okay, I want it to equal u versus the water. So that means the velocity of u plus something has to equal the velocity of something relative to the water. Because the y's got to be in the front and the w's got to be in the back. So what's connecting you and the water? The boat. So we're going to go B here and B here so that it crosses. Now, are these in the right order? We have YB, YB, BW, BW. Okay, they are in the right order. So we can just plug them in now. If they were not, if this was like WB, then we'd have to make it negative to make it work. But they're perfect, so we don't have to mess them up. Now, the problem with this is when we do plug it in, we have 2 meters per second at 45. And we have 10 meters per second at 80. So we have these in vector form. Remember how to add up vectors? Remember what we do when we add up vectors? Components, cosine, sine, all that nonsense. So x for the first one is going to be 2 cosine 45 I hat plus 2 sine 45 j hat. And then our other one is 10 cosine 80 I hat plus 10 sine 80 j hat. Anybody have questions on that? Why did I do that? Does anybody need to know why I did that? No? You guys are all good? All right. Basically, they're vectors. We have to have both the x and y component. Okay, since we're adding these things together, because that's what we said our equation was going to be, we're going to add them. If it was subtract, then we would do negative, and we're going to switch the sign on this one and this one if it was negative. But it's not. So positive, it goes. Okay, we need to do some calculations here before we can add these things up. We're going to simplify. 2 cosine 45 gives me 1.41. And 2 sine 45 is also 1.41. I hat and j hat. And we have 10 cosine 80 gives me 1.74 I hat. That's an I. And 10 sine 80 is 9.85 j hat. There you go. Okay. Now we're going to add up I hats. It gives me 1.41 plus 1.74, 3.15. and 1.41 plus 9.85. 11.26. J hat. Okay, so this is going to be our vector VYW, but it's in component form. So we need to figure out what it would be in vector form, right? We have to use this. Okay. So we're going to find the magnitude of this vector, square root of 3.15 squared plus 11.26 squared. Make sure you put parentheses around that so only the square root's the whole thing, not just the front. And we get 11.7. And then put your unit on there. And then we got to find the angle of this thing, tangent inverse of y over x. Now, they're both positive, so we are going to ignore there doesn't need to be an adjuster. It's already perfect, just the way it is. Okay, so tangent inverse of 11.26 over 3.15 gives us 74.50 degrees. So this is saying that if we're on the boat, we walk at a 45-degree angle this way, and this is 80 degrees. In all, compared to the ground, we'll be going 74 degrees, and we'll be going faster than the boat, which makes sense because we're kind of going towards the front of the boat a little bit. So we're not adding completely, because if it was all in the same direction, it would be 12. So it can maximum would be 12. But since we're angled a little bit, we're just a little bit slower than adding those two things at 11.7. So our answer does make sense. It would be weird if it was like 15, because that means that we're going faster than we would if we were going in the same direction. Okay. So this isn't super easy, this part, because it has to bring in those vector parts. But if you can get to this part right here, the rest of it's vectors. This is the physics. That's the stuff you already know. And this is the hardest possible question because these angles aren't 90 degrees to each other. Most of your stuff will be either 90 degrees to each other or in the same direction. So you guys ready for a quick question? They're so excited today. Ooh, there we go. Okay. Here is the very first clicker question for you. And it says, Donna is traveling in a train due north at 30 meters per second. What is the magnitude of the velocity? So basically, what's the velocity of Donna with respect to another train that is running due south at 30 meters per second? So basically, we have a train going this way at 30 meters per second, which Donna is on. And then we have another train that is going 30 meters per second this way. So how fast is that second train going compared to Donna, since she's already traveling 30 meters per second towards it, and it's traveling 30 meters per second towards her? Which one would be correct? Do you have homework? The outlines? You weren't here yesterday.
I wasn't here yesterday,
Okay.
and then I came in like a minute before the bell rang one day. So I did the outlines.
Yeah. But you can hand it in for free. You don't need any like passport.
Okay. I wasn't here to get the problem for the review either.
It's up on the board right there. You see Mondays under honors physics.
Chapter 6?
Yes. Chapter 5 review, chapter 6 out.
Okay.
And the homework from Monday too. Did you have that? It was never mind. The review and the outline is the only thing that you're missing for the last week, and the test case. So you probably don't want to take the test till you do the review.
I had to take that before Thursday.
Well, kind of.
Yeah, probably.
Because we get a couple of days to get entry rates, so you could do it next week if you need the time.
Really? Alright.
All right, how many we got? 2, 4, 6, 8, 10, 18 people. We're missing 3 people on the clickers. Okay, here we go. if it helps, kind of think about how fast would it hit Donna. Like she's 30 towards it, 30 this way. So what you've said here is that 30 train here, 30 train here, 0. That actually isn't working because the only way for you to have 0 is if the train was going the same direction as Donna relative to her. The train going this way and a train going this way, that train would be 0 to her. But if you have a train coming this way 30 and this way 30, well, imagine she's at 0. Now it feels like the train is coming her at 60 because she's also traveling towards it. Okay, so let's look at the naming when it comes to this stuff. The naming is really key. I'm going to tell Donna's on the northbound train. So her and the northbound train are basically one unit. So I'll just call it the northbound train. So the northbound train is traveling relative to the ground at 30 meters per second. And then I should do this. 30 meters per second north. So basically positive 30 meters per second. And then the southbound train, the velocity of the southbound train relative to the ground is traveling 30 meters per second south. So it's basically negative, down. Okay, so now I want to figure out how fast Donna is going to the ground. And Donna and the northbound train are the same thing. So I'm looking for the velocity of the northbound train relative to the southbound train. So that means that my equation is going to be north to the ground plus ground to the south. That make sense? Anybody stuck yet? No? Okay. So that means that I can get the grounds to go away. Now the problem with this is the north to the ground works, but the south to the ground is backwards. So that means I need to make it negative. And then here, so it'll be negative a negative 30. So in the end, you actually end up with 30 plus 30. Basically, imagine that Donna doesn't know that she's moving at 30 meters per second. All she sees is the other train coming at her twice as fast because 30, 30, 60. So basically, when they're in opposite directions and they're traveling towards each other, imagine one is 0 and you make up for that as the other one is coming. It's confusing, isn't it? Okay. So, question 3. I know I skipped 2. Don't worry. It's okay. This one, same sort of idea. So, like what we did in the last one. A jogger on a riverside path sees a rowing team coming towards him. If the jogger is moving 10 kilometers an hour and the boat is moving 20 kilometers an hour, how quickly does the jogger approach the boat? So basically they're coming, here's the jogger and here's the boat, just like the two trains. So what would the answer be?
Is the rowing team running or?
They're rowing towards the jogger. Boat, jogger. Jogger's going this way at 10, boat's going this way at 20.
Oh, you mean they're on the water, but like
Yeah.
parallel on the.
Yes. Imagine the jogger's running on the water.
No, I mean my row team.
Don't read too much into it. The people that write these questions are physicists, not like actual real people. They probably don't know anything about rowing.
Or real life.
Oh, well, hey now.
Just physics. People.
I know a little bit about real
People can't
life.
run on water.
Not much, but a little. Okay, we're still missing one person.
Our windows can see only the middle.
These ones?
Yes, they're outside. You gotta stay.
This one is, that one's not. In the back. The very far back one. There's like one back there that's not. But yes.
So it's not that dark outside?
Not quite that dark now. All right, here we go. We got everybody's answer. So just like the last one, how we added them together, we are going to add them together again. So you should have gotten 30 kilometers an hour. So we're learning. Okay, now here's one with an angle. And this is a good one to start us off on because this is very similar to what you're going to get on your homework. It says a bus is traveling from west to east with a velocity of 11.5 meters per second. A marble rolls on the surface of the bus floor with a velocity of 0.2 meters per second north. What is the velocity of the marble relative to the road? So this is where the vector stuff comes in. So let's take a look at that. Make sure that worked. It did work. Look at that. Okay, reading through our problem, we say the bus is traveling from west to east. This is relative to the ground. So the velocity of the bus to the ground is 11.5 meters per second east, which is 0 degrees, right? And then a marble rolls on the surface of the bus floor with a velocity of, so this is the velocity of the marble relative to the bus, because this says marble rolls surface of the bus. Okay, so marble to the bus is going to be 0.2 meters per second. And this one says north, so that one should be 90 degrees. And the question is, what is the velocity of the marble relative to the road? So that's like the ground. Question. Say it again?
Can you draw, how did you get 90? Can you draw the little...
It just said north.
Yeah, but how did you know that? I'm confused.
Never eat soggy waffles.
Why is it 270?
270 is straight down the south. You don't remember our protractor, the little printable one?
I still have that. Yes, I did.
Yes. Well, east is always 0, and then everything else falls into place. Good? Okay. All right, so now we're going to build our equation around this. The velocity of the marble relative to the ground. So that means the velocity of the marble relative to something plus the velocity of something relative to the ground. What's going to connect the marble to the ground?
The bus.
Good, the bus. So we're going to put the bus in here so that it cancels. Now, are these already set up the way they're supposed to be?
Yeah.
Yes, so we don't have to do anything. We're just going to straight up add our vectors together. Are you guys ready for the vector part?
Yeah.
Okay. So we got x, we got y. We're going to do MB 0.2 cosine 90 I hat plus 0.2 sine 90 j hat. And then we're going to do the BG part, so 11.5 cosine 0 I hat plus 11.5 sine 0 j hat. Now, what's nice about 90 and 0 is that they're only going to have one component, because it's either straight up, so there's no x component, or it's straight right. So it's only x component, no y component. So these simplify very nicely. So basically, you're going to get, this is going to be 0 I hat. This will be 11.5 I hat. This is going to be 0.2 j hat, and this is going to be 0 j hat. So when you add it up, you should end up with 11.5 I hat plus 0.2 j hat. Everybody still with me? Okay, and then from there, magnitude and direction. And I'll let you do that. And you can choose your answer. I think it started. It is. And we'll go ahead and do, this is our last question. I know it was really short, but we only have about 3 or 4 minutes left in this class. So when you're finished with this question, put your clicker away. You don't know how to use a calculator? Or just that one? Oh. Okay, type in your equation. Okay, so square root Okay, here we go. Here's the answers. Now, since 11.5 is much, much, much bigger than 0.2, it doesn't really change it too much. So it's still about 11.5. And I see everybody got the right answer. That's good. It's good to know. All right, your homework tonight is 22 through 31. And here are the high scores. Probably everybody. Oh, we got 2 high scores. Look at that. All right. Oh, no.